Okay, so polynomial division is what we're going to be looking at here. They like to make it nice and complicated, but hopefully if we remember back to our basic division in primary school, we can then do the same thing, apply the same process with division of polynomials, okay? So to work out something like this. Now, before you get carried away and go, oh, this is way complicated with long division, we will be showing you a synthetic way to do the same thing, really easy, but the synthetic division won't work if I'm dividing by, won't work as well if I'm dividing by a quadratic that doesn't have real solutions or real zeros. So anyway, we're going to start off by going back in time and seeing how can we solve something like 3,517 divided by 6. Now I know normally there's a shortcut way to do this, but I want to go and show you the long division process because that's what we're going to apply to our polynomial. So have patience, grasshoppers. Okay, so we set up our long division. We put the 3, the 5, the 1, the 7, and we pop our 6. And we ask ourselves a really important question. Does 6 go into 3? Clearly not. So then we have to say, well, does 6 go into 35? And yes, clearly it does. What do we have to times 6 by for it to go into 35? Right, and it goes in 5 times. So we pop that up there. And then we're saying, okay, if it goes in 5 times, so we have to multiply that. 5 times 6 is 30. We pop that underneath and we subtract. 35 take 30 is 5. And we bring down the 1. And we go through the same process again. And we say, how many times does 6 now go into 51? 6 times what gives me 51? 6 eighths are 48. So we then times that. 8 sixes are 48 and we pop that there and we subtract. Okay, 51 take 48 is 3. Once again, we bring down 7. 6 times what gives me 37? Well, it's going to be 6. Once again, you multiply 6 times 6 is 36. And so we're left now, we haven't got any more. Like if we wanted to go further, we could go decimals and so on, but we don't want to do that in, especially with the polynomials. We don't need to do that. So what we can now say is this answer, 3,517, equals the 5, 8, right? This is our answer up here. Our 5, 8, 6. Okay, with a remainder 1, so we could say remainder 1. I don't know if you remember your teacher doing that. Or the better way is 5, 8, 6. Okay, and we say it's 1/6, where 6 is the thing that we were dividing by. So if we look up here, that's all that this is saying. Okay, in our case, our Q of x, that would be this answer here, right, or this one, and our remainder, right, so technically you can put a plus there if you want to, our remainder is the 1 over the thing that we divided, so 1/6. You can also just write it like that. Okay, so now we're going to apply the same process, but we are clearly going to do it with polynomials. So we're going to do the same thing. We're going to set up, go green to make it a little bit different. We're going to set up our division. But what we put in here now is our 2x cubed plus 7x squared. Okay, so in this case, what we're going to do is we will look at this, focus on this x, and we want to say that x times what gives me 2x cubed, right? What gives me 2x cubed? And clearly, right, it's x times 2x squared gives me the 2x cubed. Okay, so this one here, I put it above the squared All right, all in a line. And now we have to multiply, so we're going to multiply all of this by 2x squared. So x times 2x squared is 2x cubed. 2x squared times 2 is 4x squared. And then we're going to subtract. Oh, that's a bit crooked. 2x cubed, take 2x cubed, no, x cubed disappeared, which is what we wanted. 7x squared, take 4x squared. We've now got 3x squared. It's time to bring down the plus 10x. Okay, now we're going to repeat what we did before. We're going to look at our x and we're going to ask ourselves, x times what gives me 3x squared? Well, clearly x times 3x. So we'll pop the 3x up here. X times 3x gives me 3x squared, and now I have to multiply all of this by 3x squared. So 3x times x is 3x squared, and 3x times 2 is 6x. And we are going to, like we did before, we're going to subtract. 3x squared, take 3x squared, no x squared. We're on the right track. 10x, take 6x is 4x. And now we bring down the 15. Keep on going. Right, look at the x. X times what gives me the 4x? Well, this time it's going to be 4. So now we times everything through. And when I say everything, my divisor here, 4 times x plus 2, that becomes 4x plus 8. And we subtract. 4x take 4x, no x. 15 take 8 is 7. To think about that. And we're done because we can't let x go into the 7. So what we can now say is, therefore, our 2x cubed plus, just rewrite, okay, so that's going to equal our answer up here. That's like our q of x there. Let's make that. Oops, don't want to delete the whole screen. That would be a disaster. Okay, so this is our q of x, and then we've got our remainder here. Okay, so this is going to be 2x. Oh, come on. That's going to be 2x squared plus 3x plus 4 plus our remainder of 7, right, over the thing that we divided by, x plus 2. So this is in this form up here, right, this one. And then you can see that if we're looking at just our polynomial, so 2x cubed, if you just wanted that all by itself, 2x cubed plus 7x squared plus 10x plus 15, how do I get rid of this divide by? X plus 2, you would times through, so that becomes 2x squared plus 3x plus 4 times x plus 2. And then when you times this term by x plus 2, because there's a divide by x plus 2, you just get that plus 7. So that's your remainder, right? So that's this form here. So hopefully you can go and practice a little bit, and we will go through any of the ones that you had issues with in class. And just a little hint, if you had a polynomial, let's say it was, instead of 2x cubed, so let's go 3x cubed, take 4x plus 7, and you were dividing that by something, so let's just go x take 1. When you set up your division, you should go 3x cubed. Now there's no x squared there, so I would actually put in plus 0 x squared. Okay, just keeps everything in order, keeps things nice and neat. So see if you can have a go, have a practice, but we'll go back over these in class.